Mars, known for its extremely thin atmosphere filled with carbon dioxide, usually appears as a faint blur in distant space imagery, but recent observations have transformed that blur into a dynamic portrait. Now, we can see the movement of dust, storms and changing wind currents in action, phenomena once invisible thanks to the remarkable imaging capabilities aboard the most recent rover mission. Among the most intense segments of this journey was the rover's dramatic arrival, often labeled the 7 minutes of terror. During this tense period, the spacecraft had to reduce its speed from about 12,000 miles per hour. This required a carefully orchestrated sequence involving a massive parachute, controlled engine burns, and the sky crane system that gently lowered the rover to the Martian ground. For the first time, this entire descent was filmed in real time, delivering not only mesmerizing visuals to the public, but also providing engineers with invaluable data for refining future spacecraft landings. Each new step on Mars brings us closer to unraveling a long-standing mystery. Could life have ever existed on the red planet? But the mission reaches beyond just scientific inquiry. It helps humanity piece together our broader role in the universe. As more data comes in, our understanding of space and our place within it becomes deeper. The descent footage, far from being mere spectacle, played a critical role in assessing the performance of the entry, descent, and landing systems. Engineers meticulously reviewed every second, looking for indications of success and areas that could be improved. Even with intense preparation, Mars' thin and erratic atmosphere always poses unpredictable challenges. Observing this landing with such precision gave mission planners a rich foundation for enhancing future planetary arrivals. Once the rover reached the surface intact, it quickly began to transmit incredible visuals of its new environment, including our first close look at Jezero crater. This site was deliberately chosen by researchers due to its potential to hold evidence of ancient life. They believe the crater once contained a substantial lake, with a delta-like structure formed by rivers that may have carried sediment-rich or historical clues. The arrival of this rover marked not just another scientific milestone, but a significant leap in how we perceive and experience other planets. With some of the most advanced cameras ever deployed in space, the rover has delivered extraordinary images and motion clips, unlike older missions, limited by the tools of their time. This rover captures the Martian terrain with unprecedented sharpness, equipped with 23 cameras, many able to film in 4K resolution. The current rover has revealed Mars with extraordinary clarity. Now, we can examine each stone, ridge, and impact crater as if standing on the surface ourselves. The color range displayed is equally remarkable. While Mars is often dubbed the red planet, the images expose a broader palette from burnt oranges and ochres to deep browns. These colors are more than visually stunning. They reveal scientific information, since minerals reflect light in different ways. Studying these shades helps researchers piece together Mars' geological past and environmental conditions. Thanks to these crystal-clear visuals, scientists are now forming the most detailed picture yet of both the Martian landscape and its atmospheric behavior. The rover that accomplished this feat, considered the most technologically advanced of its kind, landed in February 2021. It represents the culmination of years of innovation and builds on the success of its predecessors. Its key missions include seeking evidence of prior life, gathering samples of rock and soil to be retrieved later, and laying the foundation for future crewed missions. The pictures and footage it has returned are the clearest ever seen from another world. The journey itself began in July 2020, when the spacecraft lifted off from Earth and traveled more than 6 months through the void of space. Landing required a sophisticated series of steps to safely navigate through Mars' thin atmosphere, a process known for its high stakes. That descent, nicknamed the 7 minutes of terror, was especially critical. Every maneuver had to work flawlessly. What distinguished this mission, however, was the onboard camera suite that documented each moment. For the first time, People around the world could watch as the parachute opened, the protective heat shield detached, and the sky crane lowered the rover to the ground with precision. These visuals captured one of the most complicated and daring landings ever attempted in space exploration. Why does all of this matter to those of us on Earth? Each new data point helps us not only understand Mars better, but also reconsider humanity's place in the cosmos. Each mission is like adding a new piece to an immense puzzle. As we uncover more about Mars' history, including its weather patterns, surface composition, and potential to harbor life, we get closer to the possibility of humans one day walking its surface. The idea of visiting another world is no longer purely science fiction. Thanks to robotic explorers, that vision becomes increasingly tangible. Mars missions have revolutionized how scientists investigate other planets and redefined what's possible. During the final moments of the rover's descent, Mission Control tracked its movement from about 121 miles above the Martian ground. As it traveled at nearly 13,000 miles per hour, the parachute deployment was a pivotal point, dictating whether the rest of the landing sequence could succeed. Each successful rover landing doesn't just achieve its immediate goals, it paves the way for a future exploration and gets us closer to resolving some of the deepest questions humanity has ever asked. Did life ever exist on Mars? Could life flourish elsewhere in the universe? These are vast questions, but with missions like this, real answers come into reach. Over the past 15 months, Mars has been a hub of activity. The rover has been moving across its surface and has now begun one of its most critical phases, the search for signs of life. In a significant moment, the rover captured what might be the clearest image to date that hints that biological activity, a potential breakthrough that could redefine how we explore space. This endeavor is a story of steady advancement and persistence. Though serious efforts began more than 20 years ago, the dream of setting robotic feet on Mars reaches back to the early years of space exploration. The planet has long been considered one of the best candidates for finding life beyond Earth. However, getting there was never straightforward. Even after orbiters reached the planet, safely landing on its surface remained a daunting task. That's when robotic rovers changed the game. The first of these, named Sojourner, touched down in 1997 as part of the Pathfinder mission. Though small and basic by today's standards, it was revolutionary at the time. A robotic machine performing research on another world was once the stuff of science fiction, but Sojourner made it real. In just 83 days, it returned a treasure trove of information about Mars terrain and materials. That success encouraged bolder projects. In 2004, NASA launched Spirit and Opportunity, twin rovers designed to explore different parts of the Martian surface. Both missions outperformed expectations. Opportunity, in particular, became iconic, surviving for 15 years and making key discoveries, including strong indications that water once flowed on the planet. The results from these missions have consistently surpassed what scientists had hoped to find. Now, with the ongoing work of the current rover, it's clear that Mars exploration is still in its early stages. We may be standing at the beginning of the most significant chapter yet in understanding whether life exists beyond our planet.